Hello! We are going to be simplifying square roots today. A square number is also referred to as a perfect square. Bear with me, my handwriting is not going to be perfect on this thing, nor will it hardly fit in any of the lines. But a square number is also known as a perfect square. Remember, to square something means take it times itself, not doubling it or multiplying it by itself. So we are going to fill in here our perfect squares in this table. If I can get this to work. There we go. So, 1 squared is taking 1 times 1, so we get 1. If x is 2 and we want to square x, then 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. To the second table, 11 squared, 121. 12 squared is 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. 16 squared, 256. 17 squared, 289. 18 squared, 324. 19 squared, I'm not really sure, ends in a 1. And 400 is 20 squared. So the purple numbers that I just wrote, those are considered perfect squares. Because to obtain them, you take a number times itself. Perfect squares. Those are the numbers that we're really going to focus on today. Gotta erase that now. So below here, some terminology that we use when we're working with simplifying square roots. A radical is a root, like a square root of a number. A radical is made up of a radical symbol and something called the radicand. So in this diagram here we have the square root of x. That expression there, that would be our radical. And then the number underneath the radical symbol, that's what is called the radicand. So x, that would be your radicand. If we wrote the square root of 132, 132 would be the radicand. So the number underneath of the radical symbol is called the radicand. Perfect square in their square roots. I'm not going to take time to fill that out because we kind of just did there above. So moving on to the back side here where we actually are going to simplify our square roots. If I ask you what the square root of 25 is, hopefully you all just said 5. Because 5 times 5 is 25, so the square root of 25 is 5. The square root of 441 is 21. Now if you didn't know that, you could throw it in your calculator. The square root of 81, 9. The square root of 625, 25. 25, 81, 441, 625, those would be considered perfect squares because there exists a number that when I take it times itself, we obtain that number. Now, we're not going to always have perfect squares to simplify. So, let me move this a little. If an expression is not a perfect square, then you want to see if you can rewrite the expression as a product of two smaller factors. Remember, the term product means to multiply, where one of the factors is a perfect square, where one factor is a perfect square. Then you're going to take out or simplify the square root of the factor that is a perfect square, and then multiply that answer and the other factor, which would still be under the radical, and multiply that number times the other factor, which most likely will have the radical symbol. Again, I apologize for the sloppy handwriting. Okay, so those perfect squares that we talked about at the beginning that we filled out on the front side, I'm going to list those up here above this, steps 1 through 4. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and there's more. Those are what we're looking to divide by. Okay, so when we go down here to simplify the square root of 27, I want to find one of these purple numbers that can evenly go into 27. I heard you say it. It's 9, and it can go in there 3 times. Oops. So, oops, wrong button. So we're going to rewrite this as a product, as multiplication. It's the square root of 9 times the square root of 3. Once you've rewritten it as a multiplication problem, then you simplify. So you ask yourself, what is the square root of 9? Well, that's 3. And you ask yourself, what's the square root of 3? Well, I don't know, because it's not on my list of purple numbers at the top. So, our final answer then is 3 square root 3. For the next one, the square root of 32. We're looking for one of these purple numbers that can evenly go into 32. 4, 16. Good, both 4 and 16 go into 32. So if we start with 4 times 8 is 32. So we rewrite it as multiplication as a product. Then we ask ourselves, what is the square root of 4? It's 2. So I rewrite that as 2. Square root of 8. It's not one of my perfect squares there up at the top, but 4 does evenly go into 8. So now I need to break down 8 as the product of 4 and 2. Again, it's all multiplication, you guys. So when we ask ourselves what's the square root of 4, we answer 2. So now it's 2 times the square root of 2. And these front two 2's, since they're outside of the radical, we're going to multiply them together, and we get 4 square root 2. Now, if you didn't hear, some others said that 16 can evenly go into 32. And that's true. The product of 16 and 2 is also 32. And 16 is one of my perfect squares at the top. Its square root is 4. We don't know what the square root of 2 is, and we can't break it down anymore. So here's our final answer, which is the same as the other one. So both ways would be correct. The bigger the perfect square is you start with, the less work. So 16 is greater than 4, so it was less work in the end to get to the answer. All right, the next two. Square root of 40. Perfect square at the top in purple that goes into 40 is 4, and it goes in there 10 times. So we rewrite it as multiplication. The square root of 4 is 2. We don't know what the square root of 10 is. It's not listed above. Nor do 9 or 4 evenly go into 10, so we can't simplify it any further. So this is 2 square root 10. For the square root of 50, one of these purple numbers at the top that evenly go into 50, 25. And it goes in there 2 times, so I rewrite it as multiplication. Then we ask ourselves, what is the square root of 25? It's 5. We don't know what the square root of 2 is, so we leave it square root 2. Now, if you would like to try the next ones on your own and pause the video and then see if you do it correctly, you can. I'm just going to keep going here, erase some of this stuff. Still using this list of perfect squares there in purple. So 135. 9 can go into 135 15 times. The square root of 9 is 3. 15 is not listed above here, nor does 9 or 4 evenly go into 15. So then we leave it as 3 square root 15. Square root of 243. 81 goes into 243 3 times. And the square root of 81 is 9. We don't know what the square root of 3 is, so we leave it as 9 square root 3. And our last one here, 108, is the product of 36 and 3. The square root of 36 is 6. We don't know what the square root of 3 is, so our